All right, let's take a look at what they're calling right prisms. I have never seen one of these pop up on a test before, a practice test, but it is on your formula sheet. And so I want to break down what it means and how to go about solving these. So a right prism is basically, think of like a wedge of cheese or a door stop, something that is triangular but also has rectangles kind of connecting it um in this way, or it could be like a lean-to shed, right, that has a triangle side and a slanty roof. It's the way that it's drawn here, I know it can be a little hard to sort of visualize, but the main things you need to get in this formula are the base, like the bottom should be the triangle side. So if it's presented to you where the rectangle is sitting flat on the ground and the triangles are sort of the sides, you need to sort of turn it or redraw it in a way where the whole shape is sitting on its triangle side. And that's how you're going to visualize the base and the perimeter and everything else. So this is sort of sitting up on its triangle side. And the triangle perimeter is a 7, an 8, and a 2. So if you just isolate the triangle part, I'm just going to redraw the triangle over here. This is just the triangle. And you see it's a right triangle. And that's important because in order to get the area of a triangle, we need to have that vertical height. And they've given that to us here. So this side is 2 inches, the long side is 8 inches, and this side is 7 inches. That's not actual dimensions that would work on a right triangle, but just pretend like these are the numbers that they would give you. Okay, so we know the perimeter, and that's important because in the equation, we have a little p, which stands for perimeter in this case. We have a height, and we have two big B's, which means two areas, the area of the base times 2, since there is one triangle here on the bottom, and there's an equal same triangle as on the other side of it. So we have to count 2 triangles, and then we're also counting the perimeter times the height, which is going to give us the 3 rectangle pieces, which are this one on the front, this one on the side, long side piece, and then the one that's sort of on the back, like the bottom, I guess, underneath this piece. So kind of hard to visualize these, but essentially there are 3 rectangles on these shapes and 2 triangles. The 3 rectangles are captured in this part of the formula, and the 2 triangles are captured in this part of the formula. So for perimeter, we're taking the perimeter of the base, which is the triangle. Remember, we're sitting this thing on its side, and it's standing up on its triangle. So the triangle is the base, and it's 2, 7, and 8 is the perimeter. So I'm going to write this out like this, equals. The perimeter is always sides added up. So I'm going to put 7 plus 8 plus 2 in parentheses. So I remember to do that first, times the height. And remember, if it's standing on the triangle, then the 12 becomes the height because it's standing upright like this. This is up, right? So 12 is our height plus 2 of our triangles. So again, we have this triangle like this, 2, 7, and 8. Area of a triangle is 1/2 base times height. This is our base. This is our height. So 1/2 times 7 times 2. 1/2 times 7 times 2 is going to be 7. So I have 2 times that big B. This whole thing equals big B. So I have 2 of those because the formula tells me to account for both triangles in the shape. Okay, so now I have everything I need to solve this. Go ahead and get this out of the way. All this. And we'll go ahead and solve this. So I'm going to do the 7 plus 8 plus 2 first because it's in parentheses, and I'm just adding those things and not doing anything else. You hit enter and you get 17. So now I can rewrite this as 17 times 12 plus 2 times 7. So I'll do 17 times 12, and I get 204 plus 2 times 7 is 14. And so that becomes 218. We're dealing with inches, and we're dealing with an area problem. So my final answer would be 218 square inches. Now, if that felt really difficult and hard to visualize and conceptualize, I wouldn't spend too much time worrying about right prisms because, like I said, I have not ever seen one pop up on a real test. That doesn't mean they're not there. I don't see a lot of real tests lately. So it's good to just kind of know what it is and what it looks like, but I wouldn't spend a whole lot of time with this. Same thing when we do the volumes. When you see that volume formula, big B times H, all you're doing there is taking the area of the base, which in this example was 7. That area of the triangle was 7, and multiplying it by the height, which is 12. So 7 times 12, and you would have your answer for volume. But I will actually show you that I'll show you how to do that next, right here. Okay, so your volume formula for a right prism is big B times little h. Again, big B is the area of the base of the shape. The base of our shape is a triangle. So the area of a triangle formula is this right here. So we're taking half of the base and the height and timesing it by the height just of the triangle. Remember, I'm talking about this shape right here, 2, 8, 7. The 8 is not relevant because it is neither the base nor the height. We don't need the 8 to calculate this piece. We needed it for perimeter because perimeter is the distance around the shape and we'd have to add up all the sides, but we don't have to include the 8 in, and actually cannot include the 8 in the area formula. So we have 1/2 times the base. We just did this, so I'm just showing you again, times the height, which is going to be 7. So big B is 7. And the height of this object, of our prism that we're trying to solve for, the height, again, is 12. So the volume of this thing is 7 times 12, which if you put in your calculator is going to be 84. And now because it's volume, we're moving to cubic units, in this case inches, so 84 cubic inches. So if you happen to come across a right prism on the test, that is how you do it. But like I said, I don't think you're going to run into these. You're much more likely to encounter rectangular prisms, cylinders, pyramids, cones, and spheres. So that pretty much concludes what you need to know about right prisms.